Hi, in this video, I'm looking at graphing some trigonometric functions that have been translated or reflected. So I'm going to start off with y equals sine of x, take away 2. And so this is going to be the graph of sine of x, but translated down 2, which means that every point on the normal sine curve is actually going to be moved 2 points down, or 2 steps down, 2 units down. So if we have a look at our graph to begin with, so if we have a look first at having a y-axis and an x-axis, and I'm going to do this between negative pi and 2 pi, so just so that we have bounds. And so if I make this be negative pi over 2 and then negative pi and positive pi over 2, positive pi, 3 pi over 2 and 2 pi. So if I think about the normal sine curve, it oscillates between 1 and negative 1. And because sine gives us the y value from the unit circle at 0 rotation, I am on the x-axis of the unit circle, which means I have no height. So that means that sine starts down at the origin and would then, every 90 degrees, would make it to either its maximum or back to 0 again, or the minimum or back to 0 again. So this is the graph of just sine of x. So that's sine of x, but I need to translate the whole thing down too. I've got to do this shift. So that means that I need to extend out my vertical axis and make sure that I've got enough space to do that. So I need to go down to negative 2 and down to negative 3. Because my lowest point is negative 1, which means that if it translates down to, my lowest point is at negative 3. And so now I've got to take every point and translate it down 2. So my origin point is going to go down 2. My maximum point up here is going to go down 2. This point is going to go down 2. My minimum is going to go down 2. And this point is going to go down 2. And same here, this point is going to go down 2. And this point's going to go down 2. And so now my sine curve is going to look like this. And remembering, of course, that these just keep going. This pattern would keep going forever if we had the space to. And that's it. That is the graph of y equals sine of x minus 2, which means that it's been translated down 2. Let's have a look at another example. So I'm also going to have a look at y equals 3 minus cos of x. Now with this, it's going to be more helpful to swap the terms. So I've got negative cos of x plus 3. So just to be clear that the fact that this means that I've got a shift up of 3, but because of that minus sitting in there, I've also got a reflection in the x-axis, because that's going to take whatever cos is and make every point the negative of what it was. So a positive 1 point is going to become a negative 1 point. So we're going to have it reflected and shifted up. So let's draw in our axis and have a look at doing this. So we're going to have, and let's change this. Let's do this between negative 2 pi and 2 pi. We can do these on any bounds. So I start drawing this. We're going to have negative pi on 2, negative pi, negative 3 pi on 2, and I'll just straighten this up. Negative 2 pi, and positive pi on 2, positive pi. It's going to be a little further to the right on my scale. Pi, or 3 pi on 2, and 2 pi. So now, if we have a look at just normal cosine, cosine on the unit circle gives us the x-coordinate. So when we start 0 rotation, the x-coordinate is going to be 1. So we're going to start up at 1. So we'll put those onto the axis. Let's make that 1 and negative 1. And so then if we start graphing cosine, it's going to work its way down to 90 degrees because we go around the circle, I reach 0, no x coordinate, and then it's going to come down negatives at pi, and then up to 0, and then up to positive 1. Down here in the negatives is going to go down to 0, then down to negative pi, and then up to 0, and then up to positive 1. So that's our graph for now, but this is just y equals cos of x. So we need to invert it and shift it up 3. So let's do the inversion first. So if we do our x-axis reflection, that means every point is going to swap to its opposite on the x-axis. So my positive 1 is going to move to there. 0 is just going to reflect to 0, so that's fine. But all my negative 1s and positive 1s are going to swap places because a positive becomes a negative and a negative becomes a positive, which means that my cosine graph is going to look like this. So now I've got negative, so I've got y equals negative cos of x. So it was our original reflected. And so now I've got to shift it up 3. So to do that, I'm probably going to want to shift my entire graph down so I've got space to shift up by 3. So if we extend our vertical axis up to give us enough space so that we can shift everything up by 3, which means that my maximum height of 1 here will eventually become a maximum height of 4 because it'll have to go up to 2, then 3, and then 4. I've just got enough space. So then I've just got to translate my inverted cosine. So not my original cosine, the inverted one, so that way I get the negative cos plus 3. And so if we do that, every point needs to move up by 3. So my negative 1 point moves up 1, 2, 3 to 2. My 0 point here moves up 1, 2, 3 to 3. This 1 point moves up to 1, 2, 3 up to the 4. 0 will go to 3. Negative 1 will go to 2. 0 will go to 3. 1 will go to 4. 0 will shift up to 3. And this negative 1 will shift up to 2. And so if I draw in the curve, we've now taken this negative cos of x and translated up 3. And so now we have the graph of y equals 3 minus cos of x. Remembering, of course, that this does continue, so this would curve back up again. Same down here, this would curve back up again and just keep on going forever. So there we go. If we want to sketch a graph of sine, cosine, or even tangent, we haven't done tangent, but the technique's still the same. We can look at just, is it translated up or down, and move the points. If it's reflected in the x-axis because it's got a negative, then we got to flip the whole thing upside down.